Explorer 1, NASA's farthest journeying rocket, continues with its astounding endeavor through space, faultlessly conveying critical data from the most profound region of the universe. For right around 50 years, this marvelous space test has upset our cognizance of space. However, actually, the space contraption has been imparting upsetting data back to Earth, leaving the entire space industry in shock. Are these disturbing data the result of a specific separate or the activities of extraterrestrials? Join us as we uncover the reality behind these staggering transmissions. Starting from the beginning of written history, analysts have been captivated by the mysteries that lie beyond our great lines. This interest incited the historic launch of the Pioneer 1 and Voyager 2 transports, among other superb space missions. These earth-shattering missions, which have been discussed for a seriously lengthy time span, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5 of that very year, Voyager 1 followed the same pattern. These twin tests, each weighing a significant 720 kilograms, similar to a small vehicle, were driven into space during a perfect alignment of the outer planets. Throughout their stunning odyssey, these fearless explorers investigated unique directions and paces, heading to a pivotal moment on December 15, 1977, when Voyager 1 surpassed its twin due to differences in their routes. From that point, Voyager 1 has transformed into a critical resource, providing us with an abundance of data and unraveling space-related secrets. Before we dive into Voyager's surprising new discoveries that dazzle the entire space industry, we ought to explore the outstanding pictures discovered by the rocket during its crucial Jovian imaging mission in 1978. At that time, Voyager 1 was situated about 265 million kilometers from Earth. From this vantage point, it conveyed a dazzling number of photographs back to Earth. In January 1979, it embarked on a remarkable 100-hour effort to capture a fascinating time-lapse film showcasing 10 rotations of Jupiter. A cornucopia of 3,750 images allowed us to observe Jupiter's great dance in unmistakable detail. In the subsequent months, Voyager 1 wandered through the Jovian moon system, where it made a striking discovery: the presence of a small ring surrounding Jupiter and, besides, two new moons, later named Métis and Adrastea. These discoveries further broadened our understanding of Jupiter's intriguing area. To ensure safe passage and prevent a possible collision with Titan, one of Saturn's moons, corrective maneuvers were executed. Pioneer 1 continued with its grand excursion around Saturn, uncovering 4 extra moons: Mimas, Enceladus, Tethys, and Dione. With the culmination of the Saturn mission, analysts decided to conclude the Pioneer planetary mission, pushing both Pioneer 1 and Voyager 2 beyond the limits of our planetary gathering, propelling through space at an astonishing rate of 325 million kilometers per year. In January 1990, another chapter began: the Voyager interstellar mission. During this stage, Voyager 1 conveyed some of the most famous photographs in history, immortalizing the Sun and the majority of the planets. One individual who played a fundamental role in broadening the mission's initial targets was the unmistakable stargazer, Dr. Vachel Sands. As part of the Voyager mission's imaging team, Dr. Sands enthusiastically pushed the idea of capturing one last set of pictures as a farewell gift to humanity. Against all odds, his unwavering determination bore fruit on February 14, 1990, when Voyager 1, situated 6 billion kilometers from the Sun, embarked on a visual trip. This is notable as the family portrait of the planetary gathering. These staggering pictures, amounting to 60 in number, added to Voyager's remarkable collection of 670 photographs during its encounter with Neptune. Voyager 2 accomplished an exceptional achievement. It recorded wind speeds surpassing 13,100 meters per second, making it the fastest wind ever documented within our local planetary bunch. As the rocket wandered within 280 miles of Neptune's purplish-blue, methane-rich atmosphere, it provided us with astounding insights into this distant, heavenly body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest inhabitants within our planetary gathering, with surface temperatures plunging to a bone-chilling -391 degrees Fahrenheit. Triton's curious features, such as its nitrogen gas-hurling ice volcanoes that pushed cold particles 5 miles into its amorphous climate, also captivated our minds. These extraordinary revelations expanded our appreciation of the vast assortment and complexity of celestial objects living in the farthest reaches of our local planetary bunch. Don't go anywhere. The Voyager 1 rocket has recently made one of its most alarming discoveries. Over the years, we must find out what it has accomplished in the latest 45 years. The achievements of the Voyager twin tests have been nothing short of extraordinary. More than 40 years ago, their initial observations of Jupiter and Saturn's moons left researchers in awe and shattered previous assumptions about these remote worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, accomplished several extraordinary feats during its journey. It made history in 1986 by becoming the first transport to fly by Uranus. Only 3 years later, it achieved another remarkable milestone with a flyby of Neptune. Up to the present day, it remains the sole rocket to have ventured on such a path. As the Voyager rockets continued their journey, NASA implemented various measures to extend their operational lifespan. Over the years, unnecessary parts and heaters have been deactivated to conserve energy, ensuring that these brave Voyagers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the researchers and specialists who have been associated with this remarkable task from the very beginning, the zenith of the Voyager missions is both a moment of pride and a hint of melancholy. Their resolute devotion and passionate endeavors have far exceeded their initial expectations. The wealth of information returned by the Voyagers has provided significant insights, fueled numerous scientific discoveries, and ignited the imagination of countless analysts and space enthusiasts. Pioneer 1 and Voyager 2 were no ordinary space tests. They were meticulously designed as stable platforms with a rotation rate more than 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the space apparatus captured images and data while venturing through the boundlessness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to astound researchers and the public alike. The shuttles started transmitting pictures of Jupiter before reaching the gas giant, showing the swirling patterns of its atmosphere. Mists and the notable incredible red spot pleased crowds at NASA's Jet Propulsion Laboratory. However, it was the revelation of dynamic volcanoes on Jupiter's moon Io that genuinely took the spotlight. Io, slightly larger than Earth's moon, ended up being the most volcanically active body in our solar system. The rocket's instruments detected distinct signals from Io, which were confirmed by the unmistakable images they captured. Towering volcanic plumes and a surface scarred by volcanic material eruptions were revealed. One of Io's most prominent volcanoes has erupted with a force multiple times greater than Mount Everest, covering an area almost the size of France. While the rocket's cameras were eventually shut down to preserve power and memory before their journey into interstellar space, it is significant that the photos they captured did not include Mercury and Mars for various reasons. Besides the Pioneer 1 and Voyager 2 interstellar tests, NASA has also operated other prominent spacecraft like Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed by Pioneer 10 on February 17, 1998, marking the occasion when Pioneer 10 became the most distant rocket. Pioneer 1 continued its lone venture for 14 additional years before finally entering the interstellar medium on August 25, 2012. Although there were no other space tests in sight to observe, NASA did not publicly announce this surprising achievement until 2013. What are the methodologies used that ensured the success of the Voyager missions? In the incredible Voyager missions, one method stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played an essential role in propelling Voyager 1 and Voyager 2 on their daring mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the rockets required more than just their own propulsion systems. They needed a boost, and gravity assist provided just that. Imagine the two bold rockets, Voyager 1 and Voyager 2, embarking on their grand tour of the solar system. Rather than relying solely on their engines, they engaged in a celestial dance with some of our solar system's heavyweight planets. This fantastic dance allowed them to harness the immense gravitational pull of these giants to slingshot themselves on their way, saving precious fuel and gaining the speed needed to visit multiple destinations. Let's delve into the basics of gravity assist, also known as a gravitational slingshot. The idea behind this maneuver is to transfer some of a planet's energy to the rocket as it passes by. Picture Voyager 1 approaching Jupiter, a massive gas giant with a gravitational pull to match. With meticulous precision, Voyager 1 approached Jupiter at an optimal angle and speed. Jupiter's gravity pulled at the rocket, accelerating it to a higher speed and giving it a significant boost. Performing a gravity assist maneuver requires exceptional accuracy. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation from its planned course. The degree of precision required is overwhelming, but the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Voyager spacecraft on an astounding journey through the solar system. Voyager 2, for instance, used gravity assist from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of crucial importance in making the Grand Tour possible. The Voyager missions owe much of their success to these gravity assist maneuvers. Voyager 1 went on to reach interstellar space, with Voyager 2 quickly following after, all thanks to the precision of these maneuvers. The concept behind gravity assist is simple, yet the execution is incredibly complex. The Voyager 2000 mission required a level of accuracy where missing any of these slingshots could have resulted in a failed mission. However, the dedicated individuals behind these missions were determined and unwavering in their pursuit of knowledge. While gravity assists played a significant role in exploring the universe, another critical component ensured the success of the Voyager missions. The Deep Space Network, DSN, often considered the interstellar telephone line that kept us connected with our bold Voyager tests as they ventured into the great unknown. The DSN, less glamorous than a spacecraft, is equally essential. The Deep Space Network is a collection of large radio antennas strategically located around the world, with locations in California, Spain, and Australia. These massive dishes, ranging from 26 to an impressive 70 meters in diameter, act as enormous amplifiers, facilitating communication with spacecraft traveling beyond our planet. The DSN captures signals and sends commands, enabling a two-way conversation between Earth and the farthest human-made objects in the universe. One remarkable aspect of the DSN is its tireless operation. It works diligently around the clock, listening for those distant signals. It is like an unblinking eye on the universe, ensuring that we stay connected with our space tests even when they are billions of miles away. The Voyager mission stands as a testament to the power of collaboration and innovation. While the spacecraft embarked on their epic journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, allowing us to explore the outer planets and venture into interstellar space. Did Voyager 1 experience a breakdown, or were aliens involved? Throughout its remarkable 45-year journey in space, the Voyager 1 space test has remained steadfast, tirelessly performing its mission. However, in recent years, specialists have observed some irregularities in its performance that have sparked curiosity and interest. Voyager 1 is currently transmitting unusual messages back to Earth, giving the impression that it is uncertain about its exact coordinates. What makes this revelation even more puzzling is that the initial data received from Voyager 1 were incomprehensible and astonishing, leaving NASA researchers baffled. Upon examination, researchers discovered that the culprit behind the distorted data was the Attitude Articulation and Control System, ACS. This embedded hardware is responsible for measuring, reporting, and adjusting the rocket's position in space. It has an antenna directed towards Earth, enabling it to send data back home. The glitch occurred when the programming unexpectedly switched to sending its telemetry data through a faulty embedded computer that had been dormant for years. NASA specialists were able to correct this anomaly by instructing the rocket to resume sending data through the correct computer. As a result, uncorrupted data from Voyager 1 is once again reaching NASA. However, the question that remains unanswered is why the spacecraft switched to the malfunctioning computer in the first place. While NASA researchers have proposed a theory that a faulty command from another onboard computer could have triggered the bizarre behavior, they have yet to pinpoint the exact cause. To get to the bottom of the mystery, Susan Dodd, the project manager for the interstellar mission, stated that they plan to conduct a thorough memory readout of the spacecraft and thoroughly examine its operations. This in-depth investigation aims to identify the issue that led to the telemetry problem. It is important to note that despite the irregular data transmission, the spacecraft itself appears to be functioning properly, and none of the rocket's fault protection systems have been triggered. As such, Voyager 1 has not been forced into safe mode, and its signal remains strong. A potential factor contributing to this anomaly is the harsh environment of space. Cosmic radiation and extreme temperature fluctuations can pose challenges to the operation of a spacecraft like Voyager 1. Cosmic radiation consists of high-energy particles originating from distant stars and galaxies. These particles can penetrate spacecraft structures, causing electrical disturbances, data signal distortions, memory errors, and data corruption. Moreover, temperatures in the vacuum of space can drop to bone-chilling levels or soar to scorching highs, putting immense stress on the spacecraft's components. Despite the rigorous testing and meticulous engineering that went into designing Voyager 1 to withstand these conditions, the harsh realities of space can still cause significant wear and tear over the long haul. Another intriguing possibility that has captured the creative imagination of some is the idea of extraterrestrial interference. Could Voyager 1's strange behavior be attributed to the actions of beings from beyond our solar system? While this notion may seem more like science fiction than reality, it is not entirely outside the realm of possibility. The vastness of space and the countless exoplanets it harbors leave room for speculation about civilizations far more advanced than our own. However, before jumping to conclusions of alien intervention, scientists are meticulously examining every aspect of Voyager 1's irregular behavior. Whether the spacecraft's anomaly is due to a technical error, cosmic radiation, or something else entirely remains to be seen. But one thing is certain: the mysteries of space continue to fascinate and inspire us, driving our relentless quest for knowledge and understanding of the universe.